Hi everyone, it's Michael. I hope that all of you are staying safe during this time, and I hope that all of you are continuing to learn and get excited about some new stuff that you're covering in science and in school while all learning remotely. So last week, hopefully, or the last lesson you did, hopefully, was the lesson that Keith made, and hopefully you all got to see his face on the video for that, where you played a game with a dice and you were able to find out if you were a droplet of water, where you would go throughout the water cycle. So remember that the water cycle is the way that water can go from all the different parts on the earth. So it can be in the ocean, it can evaporate up into the clouds, it can condense into rain, it can condense into snow on glaciers, and it can pass through plants and animals. And so hopefully you all had a lot of fun with that. And so this lesson is a follow-up to that one. And you're going to build a model of the earth. And the way this model is going to work is it's going to show you how water can go from one system to another. And there are going to be a couple important questions that you're going to be able to address with this. For example, why is the ocean salty but rain is not salty? Why is it fresh water? And how does evaporation, which was a vocab word from last week that we're going to talk about again today, lead to evaporation of the oceans and other parts of water, lead to precipitation and the way that clouds form in the air and that rain falls to the ground. And we're going to build this model all with the materials we have right here. And so we're going to talk about this in a moment, but we have salt, just a cup of water, we'll need a lot more than this, plastic wrap, and then 2 differently sized bowls. And hopefully by the end of this experiment, which should take about 24 hours and you can leave it out, you'll be able to understand how water moves from one area to another and how it changes. So now hopefully you can see the handout that I made that you should also have to complete this lesson. So now we're on my computer, and let's go through a little bit of this lesson plan, and then we can get filming to actually make this model. So first, let's look over our vocabulary. So a lot of these terms were introduced with Keith's game, with the water cycle game, and they're very important. So we need to remember that evaporation is the process of water turning from a liquid to a gas. For example, evaporation occurs when liquid water turns into steam when you boil a pot of water. Condensation is the process of water turning from a gas to a liquid, so it's the opposite. A good example of this is if you were to go into the bathroom or, go up to a mirror and breathe on it, you can see that the mirror gets kind of foggy. That's because the water vapor in your air, the gas, is going to hit that cold surface and it's going to condense and turn into liquid. And so condensation happens when a warm water hits something cool. And precipitation is a term that we use a lot to describe the weather. Precipitation is water, ice, or snow that falls from clouds back to Earth. So any time that the clouds release water and rain or release snow, we call that precipitation. And it's the process, the way that water in clouds can reach the Earth. So let's consider 2 quick questions first. And so I have these under our do nows, which remember as we used to do in class. We would always start the lesson with do now questions. So the first one is, how can water get from the clouds to the ground? And so just think about it from last week, and you can write it down in your notebook, or if there's any other handout that the teacher might give you. And the second question is, how can water get from the oceans to the clouds? Now this one's a little bit trickier, right? Because we see rain fall from clouds all the time, but we don't oftentimes see steam rising from the ocean or from lakes, right? It's a little unusual, but water has to get from the ocean to the clouds, to the atmosphere. And that's the process that we call evaporation. And this specifically is the question that we're going to talk about and run an experiment today to learn about. So let's go down a little bit. We're going to go down to the bottom here. And so as you can see on this little diagram, you can see that evaporation is a process where water from the ocean evaporates into steam and into clouds. And the clouds are going to get condensed. And as they get heavier and heavier and fill with more and more water, it's going to release that water as rain, as precipitation. And so this part of the water cycle is what we're going to talk about today. So join me, and you'll see me in person again in a few seconds, and we're going to go through the procedure for setting up this experiment. Okay, can everyone see me? Now let's get started to actually make the experiment. So step 1, place a large bowl on a table. We've got this bowl right here, and we're going to fill it with water. And so I've got 2 large glasses of water that I'm putting right in. Step 2, put 2 handfuls of salt in the water and mix it together. You really make sure to get a good amount of salt in there. You should see it kind of change, really kind of change a little bit of color, if you can see that, and let it, mix it around a little bit so you can make some salty water. If you want, you can even taste it to see if it's salty and gross enough for you. The next thing we're going to do, and this is important, we're going to take our second bowl, our smaller bowl, and put it right in the middle of this bowl. It's really important to not get any water into the second bowl. So, depending on how much water you have, it can float or it can rest on the bottom. Try and get it to rest, because right now you can see this bowl is kind of floating around. It'll be okay, but it's really easier if it's just sitting on the bottom of the bowl. And now we're going to cover the whole thing with plastic. The whole thing is now covered in plastic wrap. And so it made a nice tight seal, kind of like if you were baking. And now I want a weight, W-E-I-G-H-T. I want something that kind of pushes it down in the middle so that when the water evaporates up the sides, it's gonna drop down right in the middle bowl. So I will be right back. So I've got a bottle cap. A coin would work well too, like a penny. And I'm gonna take that and I'm gonna put it right there. And that's just gonna put a little bit of weight down so that most of the water will fall back into that small bowl. And now we're gonna take this over outside and we're just gonna leave it outside for a bit. Okay, welcome to the outside part of my apartment. And here is our experimental setup. All I did was move it outside. And I'm gonna leave it right here for 24 hours. It is about 2 p.m. on Wednesday, April 15th. And if you can't leave it outside, leave it in a sunny window. And an important observation to make if you want to check on it in a couple of hours is to see if you can see any steam build up on the plastic. That'll be really important. That'll show that our experiment's working. So I will check in back in with you all in about 24 hours and we can see what happened. Okay, welcome back. So as you can probably tell by the growth of my beard, we did not wait one day. So one of the nice things about filming this video in real time is that you actually get to take a look at the scientific process and see how scientists every day kind of learn from experiments to inform new ones. And you kind of get smarter as you run an experiment over and over. So it is actually Sunday, April 19th. So we waited 4 full days. And a couple of other things. The bottle cap that I had was replaced with quarters because quarters are heavier. So I would recommend using marbles as it's written in the handout or 2 quarters and it'll help push down the plastic wrap. But let's take a look. So when we take off the plastic wrap, let's see if you can see it on the screen. There's a ton of water coming off of it and a ton of little water droplets. So while it was out in the sun, a lot of this water evaporated and cooled on the plastic, and you can see that. So now let's pour out the water. So I have my tiny bowl that was sitting in the larger bowl, and I'm gonna pour it out into this small cup. There's not a lot of water. Right, so just a little bit. I have some tips in the handout that you're gonna get with it that are gonna help you, that are gonna help improve on this experiment when you do it at home. But I would say wait a minimum of 3 full days after you put it out. But you can always check on it right in the middle of the day. You can go out there and you can see this water forming on the surface. And now let's pour out the water into a separate bowl. So there's a lot more water here. And I'm gonna pour some of it into this glass. So here's the water that was in the large bowl. And as you can see, there was a small amount of water that got into the smaller bowl. I'm not gonna do this right now, I'm gonna leave it for you. both you all to do, but you should taste the difference between these two waters. Don't drink it. Do not drink all this water, but just kind of like dab your finger on it if your fingers are clean, or take a small spoon and just kind of taste it. And write down in your handouts and in your science notebooks the difference between the two of them. And so think about the experimental setup we did today, about how water goes from this large bowl, it cools on the plastic and falls into the smaller bowl, and relate that to your experience with the water cycle game that you and Keith did earlier in the week. So I look forward to hearing from you all about how these experiments went and the observations that you had, and I hope to see you all soon.